Let S be the sum, P be the product, and R be the sum of reciprocals of n terms of a GP. Prove that P square times R raised to the power n is equal to S raised to the power n. So S is equal to A times 1 minus R raised to the power n over 1 minus R. We are also given with that P is the product of n terms. So P is equal to A times AR times AR squared and so on up to AR raised to the power n minus 1. So here A is multiplied n times. So A raised to the power n times R raised to the power, the powers will add up. So it will be 1 plus 2 plus 3 and so on up to n minus 1. Here 1 plus 2 plus 3 plus so on up to n minus 1. This is an AP, and we can find the sum of this by using the sum of AP formula, which is the number of terms. Here number of terms will be n minus 1. So n minus 1 over 2 times the first term, which is 1, plus the last term, which is n minus 1. We can cancel out 1. So it will be n times n minus 1 over 2. Therefore, P is equal to A raised to the power n times R raised to the power n times n minus 1 over 2. Now, R is the sum of reciprocals. So R is equal to 1 over A plus 1 over AR plus 1 over AR square and so on up to 1 over AR raised to the power n minus 1. This is also a GP in which the first term is 1 over A and the common ratio is 1 over R. So the sum will be 1 over A times 1 minus 1 over R raised to the power n divided by 1 minus 1 over R. If we simplify this, we get R raised to the power n minus 1 over A times R raised to the power n minus 1 times R minus 1. So now we know the values of S, P, and R. S is equal to A R raised to the power n minus 1 over R minus 1. P is equal to A raised to the power n R raised to the power n times n minus 1 over 2. And R is equal to R raised to the power n minus 1 over A times R raised to the power n minus 1 times R minus 1. And if we start with the left-hand side, which is P square times R raised to the power n, which will be equal to P square. So A raised to the power 2n, R raised to the power n times n minus 1 times R raised to the power n will give us R raised to the power n minus 1 raised to the power n divided by the denominator raised to the power n. So A raised to the power n, R raised to the power n times n minus 1 times R minus 1 raised to the power n. We can cancel out R raised to the power n times n minus 1. 1 of A raised to the power n will cancel out. So we'll be left with A raised to the power n times R raised to the power n minus 1 whole raised to the power n divided by R minus 1 raised to the power n, which is nothing but same as S raised to the power n, and that is equal to the right hand side.